There are lots of different ways to handle animation and motion in TouchDesigner projects, but one of the more common ones that I see people using can be a little bit problematic. So I'd like to explain why it's bad and what a good alternative is. To do that, we're going to build out a little example scene component and then try a few different approaches to see which one works best. But before we get into that, we need to talk about the concept of absolute time, which is where TouchDesigner keeps track of how long it's been since the program first opened. It's accessible through a Python object named absTime or absTime that you can use in expressions or scripts. The way that it's supposed to work is that it just continuously increases as long as that power toggle, the kind of 0 and 1 button in the top toolbar, is active. And that includes when the timeline is paused, although it looks like, at least in the current 2025 builds, pausing the timeline does actually pause absTime as well, which I'm fairly certain is a bug and will hopefully be fixed soon. Though even accounting for that bug, you'll still notice how it doesn't wrap around when the timeline does. So as long as things are running, it's just counting upwards. absTime is convenient, which is fine, but please don't use it, except in quick little experiments. Side note, I did recently do a video about the importance of that sort of, anything goes approach for experimentation, but for anything more serious, don't use it. It's really hard to manage, especially if it's scattered throughout your project. Just wait until you get a creative director walking up to you and saying, yeah, that's nice, but can you just slow it down a little bit? And then you panic and realize that all the timing is scattered across 20 different parameter expressions all over your project, and you have no coherent way of slowing it down a little bit. So let's try to avoid that situation. Let's get started building out a little example scene to illustrate this. We'll start by doing it the bad way, and then we'll clean it up. Create a base comp, and we can name it scene. And then jump inside. Let's make a box sop. And then coming out of that, a transform. And mess with the rotation a little bit just to get it so it's not, totally aligned to the axis. And then let's add a copy sop coming out of that. Set the number of copies to 2. And then for the Z scale, set that to -1. Then drag out from that and create a geocomp. So we're just doing a basic little 3D scene render setup here. Now let's create a camera comp and a light comp. For the light, let's set the position to like 2, 2, 4. And then let's create a render top. Drag out from that and create an out. And then you can either switch on the display to show it in the background there, or you could right-click it and open a viewer. The exact contents of what's going on in there aren't super important because we're mostly just going to be focusing on how we're setting things up. Now let's animate the rotation using absTime. So on this transform sop, expand this rotation parameter, and then for Rx, clear out what's currently there, and then type in abs, capital T time, dot seconds, all lowercase, and then times, let's say 30. So it's going to rotate 30 degrees every second, and it's just going to continually do that as long as Touch is open. Then for the Z part, let's clear out 0, or whatever is currently there, and then do another version of this, so abs, capital T time, dot seconds. And then this one, let's do it a little bit differently. We'll do like 38, just so that they're not at exactly the same speed. Then let's add some back and forth motion to the light here. So expand the translate, and then for translate X, clear out what's currently there. And then we can use an expression like naf dot sin or sin, parentheses, abs, capital T time, dot seconds, times, let's say 2, and then parentheses, and then times 5. this is going to move it back and forth. And the 2 here is controlling how fast it goes, and the 5 is controlling the range of that sweep back and forth. So we're good, right? Sort of. I mean, it is moving in time, and it's doing the things that we have currently set it up to do, so that's good. But what happens when we want to slow it all down a little bit? We now have 3 different expressions that we need to update. And this is a really simple scene. This could easily be a whole lot more than just 3. You could even have, multiple nested layers of components with expressions all the way down through it and so on. So let's add some speed controls as parameters on the parent component. Right-click in an open spot in the network and do Customize Parent Component. Let's add a float parameter called spin speed x. Add that. And we can set the range here to -1 to +1. Then right-click on that parameter name in the list here, do copy, and then paste. And we're going to change the x2 to z. If you want, you can also do a speed for the y-axis, but I'm not going to do that for this video. Then let's add another parameter. This one's going to be called light speed x. Let's add that. For this one, since it's periodic, it's going back and forth, having a negative speed doesn't really, wouldn't be that helpful, so let's just keep it at a 0 to 1 range. Now we need to update each of these expressions to include these parameters. So let's go over to our transform stop, and then we can close the component editor dialog. Then for this first expression, at the end, take what's currently there and just add times and then parent, open and close parentheses, .par, and then capital S, spin, and then the rest of this is lowercase, speed x. And then we're going to take that whole expression here, copy that, and in here, let's paste that over what's currently there, and then change that x to a z. And then to give us a little bit better of a range to work with, let's change both these 30s to 45 or so. Then go over to our light, and in this expression here, right after absTime.seconds times 2, but before that parentheses, put in times and then parent, parentheses, open and close, .par, and then this one is going to be light, capital L, and then the rest lowercase, speed x. So everything stopped, and that's because all of our parameters are currently set to 0. So let's right-click in an open spot in the network and do open parent parameters. Go to this custom page, and now we can set those speeds there, and it's going to influence how fast things are moving. Though you may notice some issues with it jumping around, which we're going to address in a little bit. It would also be nice to have just one overall slider for, the speed of everything, so that we can kind of just quickly slow everything down or speed everything up and not have to go through each individual parameter and do them separately. So right-click in an open spot in the network, do Customize Parent Component, and then this one, let's just call it Speed. And add that. We can move it to the top of the list. And for this, let's set the default to 1, and then the maximum range, let's set that to 2. And we don't need negative in there since we've already got the ability to flip which direction things are spinning on those individual parameters where it matters. So then we can close this component editor dialog. Then we need to update those expressions again to make use of this. So we can close this parameter dialog, go back over to our transform. Let's expand this to give ourselves a little bit more room. And then right at the end for this one, we can do times and then parent, open and close parentheses, .par, and then just capital S speed. And we can copy that whole bit there with the times and the parent and par.speed, and just paste it at the end of the Z expression as well. And then we can go over to our light, and here, expand this, And right after light speed X, let's paste that in here. Then we can right click and do open parent parameters, and we've got this one speed that will control how fast everything is moving. So let's take a closer look though at what happens when we adjust those speeds. So I'm just going to switch on the viewer in the background here. So right now, if we adjust any of these speeds, you're going to see that things are jumping around. So if we start, at a speed of 0 for this, and then we want to increase it, it jumps all over the place before it kind of starts going just at that speed. And for the light, anytime that we adjust this, you can see that we're getting that flickering there, and that's because this value is jumping all over the place. Same thing applies to our central speed control. We can't really adjust the speed without things jumping around. So how do we fix that? If we stick to using absolute time, we can't. And so it is time to stop using absolute time. Instead, what we want to do is use chops. So let's close the parent parameters here. And we're going to start by taking those parameters from that parent component and pulling them into a chop. So let's create a parameter chop. And for the parameter list here, clear out that star. And we're only going to grab the individual speeds. So you can grab spin speed X, spin speed Z, and light speed X. Then drag out from that and create a math chop. And here's where we're going to apply our kind of global speed control. So over on the multiply add page, extend multiply here, clear out that one, and here we're going to do parent parentheses, close parentheses, .par, S speed. You could also open the parent parameters like this and drag the speed on here and do referenced to essentially the same thing. Then let's give ourselves a little bit more room here. And drag out from this math chop, create a select. And for the channel names, going to clear out that star and just select spin speed X, spin speed Z. You could also do a pattern expansion there if you want. And for the name here, for rename to, here we'll use a little pattern to R and then open square bracket and then X and then Z and then close square bracket. So that's going to rename it to RX and RZ, which happen to be the names of the parameters that we want to be mapping onto. Doesn't have to be exactly the same, but can be nice to just kind of keep track of things like that. So just giving ourselves a little bit more room there. Then let's drag out from our select and create a speed chop. This is going to count up or down depending on whatever the speeds being passed into it are. If you want to have it reset to 0, you can hit the little reset button here. You can also tell it what value it should reset to. You can also specify limiting in here if you want it to kind of wrap around once it hits some particular bound, and you could do different approaches for that. We still want to get these values into a more reasonable range for angles in degrees though. So let's add a math chop. And on the multiply add page, let's set this to 45. And let's add a null chop at the end. So now for a little mini optimization trick. You'll notice by looking at the line connectors here that this speed chop is cooking every frame and it's sending out values every frame. The math chop is also cooking every frame and it's sending out values every frame. If we want to make things like ever so slightly more efficient, we can swap the order of those. So if we put the math in front of the speed, then that math only cooks when our speeds change. So it doesn't make a huge difference, but it's generally good practice to kind of have fewer things cooking. So then let's use those channels, activate the viewer on the null here with a little plus, select our transform SOP, and then drag this RX onto that RX parameter, do chop reference. You could also do export if you want, and then same thing for Z. Then let's do the light. And to do this one, we're going to use an LFO. So let's create an LFO chop. LFO does a periodic value. So right now it's doing a sine wave. You can have it do other types of waves if you want. Unlike the speed chop, it doesn't have an input that tells it what speed to run at. So we're going to need to use a little expression. And since we're going to be referring to values from these channels, let's stick a null in, just give it a little name. So right after this math on that connector, you can do insert operator and then do null. And then let's call this speeds. Then on the LFO here, we can expand the frequency here, hit the little plus on the speeds chop, and then grab this light speed X channel, drag it onto frequency, and do chop reference. Then on the amplitude, let's increase that to 5, since that's the distance that we want it to go back and forth. And on the channel page, let's give this channel a more accurate name, so we can just call it TX, so translate X. And then create a null coming out of that. You can name this if you want. On the light, let's activate the viewer on that null, drag the TX channel onto translate X, and do chop reference. And then we can deactivate those viewers if you want. So now let's take a look at what happens when we adjust the parameters. So right-click in the network and do open parent parameters. Now we can adjust the speed here, and things just stop if we set it to 0. It doesn't jump around and then stop. It just stops wherever it is. If we increase it, it will smoothly increase or decrease that speed. We can adjust the individual parts, and it will handle that pretty well. So this gives us a nice clean way to control the speed of all these different things. We also set ourselves up with a single parameter that we can use as kind of like a global speed control. There is one more little caveat that I should mention about speed-based controls, which does actually also apply to using absolute time. This is based on some ideas that TouchDesigner DMX wizard Pete Thornberry brought up in my Discord server. If your project is going to be running for a really long time, any value that's continuously increasing is eventually going to hit a limit. That limit might be something that, is based on like floating point overflow numbers that you probably don't want to have to pay attention to. So it can be really useful to explicitly set some limits on the speed chop so that it will eventually wrap around and you can kind of control like when that happens. Another option would be to have like a timer or something that periodically pulses this reset to just kind of like set things back to 0. For the LFO, that's not really necessary since it's a continuous value, but if you want to have things synchronized or whatever, you could reset that as well. There are also potentially issues with floating point numbers that are what chops use and also what absTime uses, I believe. The numbers get a little bit less precise the further away they get from 0, although, to be honest, I haven't really paid that much attention to this in most projects. So it's sort of up to you when you want to handle that reset. But for long-term installations, it's usually good to have some kind of periodic reset. So you might do it, at midnight on a Sunday night or something, like every week. And just to make sure that values don't, grow outside of ranges where things start to get weird. Anyway, hopefully you found this helpful. I've been trying to think of more of these kind of like smaller, more specific topics to cover, focusing on challenges that people tend to face in TouchDesigner. So let me know in the comments if you have any other topics that you want me to cover. And if you want to support me in general, consider subscribing to my Patreon. You'll get early access to tutorials and file downloads and Discord access and a bunch of other stuff. Anyway, thanks for watching, and make sure to like, subscribe, and leave a comment.